Assalamualaikum and good day everyone. Right, so for today's class, we will discuss on R&R, subjective questions, set D. Okay, we'll try to discuss selected questions from section A and section B. Okay, so as you all know, this set has 7 questions altogether. Have 10 questions altogether. So section A ada 3 soalan, section B ada 7 soalan. So we try, Madam akan discuss few questions lah yang Madam dah select untuk kelas hari ni. Okay, so without waiting any further, let's discuss on the questions. Okay, so kita tengok dulu section A kat sini. Okay, so untuk section A, Madam nak go through first question number 2. Okay, so if we take a look at question number 2, number 2A is on the parametric equation. Okay, so kita nak buat derivative from given parametric equations. So parametric, this one relate to parametric differentiations lah. Okay, parametric differentiations. So yang ni yang awak perlu study balik kalau you nak go through soalan ni lah, kalau awak tak sure macam mana nak jawab soalan ni. Okay, so we are given this equation x equals to 3t minus 1 over t, and also equation of y equals to t plus 3 over t. Okay, t is not equal to 0. We need to show that dy dx kita akan dapat t square minus 3 over 3t squared plus 1. And then we need to find the second derivative. Okay, so ada 2 parts lah for these questions. Okay, so the first part is for us to find the dy dx, and the second part is to find the second derivative. Okay, so untuk nak dapatkan the first part, of course we have to start again with our equation of x and y. Okay, so from our equation of x, we have 3t minus with 1 over t. So this 1 over t, because we want to try to differentiate later on, okay, so we can directly change this to t to the power of negative 1. Okay, to make it easier for us to differentiate. Okay, for the second part, we have equation of y. Okay, y is t plus 3 over t also. So we change this to t to the power of negative 1. Okay, so because we want to find dy dx, so on the side here, we understood that we need to use the parametric formula, the chain rule, right? So our chain rule is dy dx equals to dy, so down here is dx, so definitely here is dt, up here also dt. Okay, so our x here, from this equation of x, we can find dx dt. Okay, so here kita akan dapat 3. Okay, so negative 1 and negative here will become plus. Okay, plus t over, plus 1 over t squared. Okay, Madam terus tukar lah. Okay, this one akan jadi t power negative 2 kan. So 1 over t squared. Okay, so tengok betul-betul kat sini, we want dt over dx. Here we have dx dt. So untuk nak inverse, kita simplify dululah yang ni. So kita akan dapat 3t square plus 1 over with t square. This is our dx dt. So we want to find dt over dx. So we have to inverse this equation, okay, untuk dt dx. So that will become t squared over 3t squared plus 1. Okay, so next part kita cari pula dy dt. Okay, so differentiate dy dt, differentiate y here with respect to t, we get 1 here minus with 3 over t squared juga kat sini. Okay, so simplify just to make it into one single fraction, okay, for dy dt. So we will have t squared minus 3 over t squared kat sini. Okay, t squared minus 3 over t squared. Alright, so try to substitute this into the chain rule. Okay, so dy dx will become, okay, again, Madam tulis balik chain rule kita, dy dt darab dengan dt dx. Sorry, so here should be dt dx. Okay, so dt over dx here. Then kita substitute lah value kita. So dy dt is this one, t squared minus 3 over t squared, and then multiply with dt over dx, which is t squared over 3t squared plus 1. So we can see that we can simplify this t squared and t squared. So the next line will have t squared minus 3 over 3t squared plus 1. Okay, so we have already satisfied lah the first part to find dy dx, which is show dy dx equals to t squared minus 3 over 3t squared plus 1. Okay, so this is the first part. So you can write down shown over here. Okay, so for the second part, we need to find the second derivative. Okay, so for the second derivative, we need to differentiate again lah. Okay, so remember to get the second derivative for a parametric equation, we will have to differentiate again d dx of our dy dx, and then we have to multiply with dt over dx. Okay, so mesti differentiate sekali lagi, lepas tu wajib darab dengan dt over dx. So part yang darab dt over dx ni yang sometimes kita tertinggal. Okay, so please be careful guys tu. So differentiate dulu dy dx. So our dy dx is, okay, Mada tulis dulu balik dalam bentuk ni. Kita ada t square minus 3 just now. Okay, t square minus 3 over with 3t square plus 1. Okay, so darab dengan dt dx kita, tadi kita dapat t square over dt dx t square over 3t square plus 1. Okay, so kena selesaikan yang dalam ni dulu. Okay, d dx of this one, differentiate this one. So obviously we have to use some rules here. Okay, so we want to use the quotient rule. Okay, we need to use the quotient rule lah actually. So to use, to proceed with our quotient rule, we take out our u and v. So u is 2t squared minus 3, and then v equals to 3t squared plus 1. Okay, so u prime is 2t, v prime is equals to 6t over here. Okay, 2 times 3, 6t. Okay, so kita akan cross and then minus, and then we have to divide by v squared. Okay, so let's put in the formula here. That's gonna be 3t squared plus 1. Okay, multiply with 2t, and then minus with t squared minus 3 times with 6t. Okay, and then divided by our v squared. Okay, so v is 3t squared plus 1, and everything square here. Okay, then we have to multiply with t squared ni lah. Okay, multiply with t squared over 3t squared plus 1. Okay, so try to simplify the numerator part first. Okay, on the top here. So we're going to have 3t squared times 2t, that will become 6t cubed plus 2t minus, okay, so multiply that in the back, t squared and 6t, so 6t cubed, and then negative 3 times 6 is 18t, so here plus 18t. Okay, over with this whole term again, so 3t squared plus 1 squared, and then times with 3t squared over 3t squared plus 1. Okay, so kat sini, bahagian numerator kita nampak 60 cube and 60 cube can be simplified. Alright, and then we have 2t plus 18t, that gives us 20t, and then darab dengan t square, so that will become 20t cube over with, so on the denominator, this is the same term. Okay, so we have 3t squared plus 1. So this one is power 2, this one power 1. So that becomes power 3 over here. Okay, so this is our second derivative. Okay, d squared y over dx squared. So that is done for question number 2a here. Okay, so next we proceed with question number 2b. Okay, so for question number 2b here, we have to find the dy dx and also the second derivative for this function, equation of y. Okay, so equation y given with e to the power of negative 2x times sine 3x. Okay, so obviously this is in the form of a product. Okay, so e to the power of negative 2x times sine 3x. So we take out u and v. Okay, so u is e to the power of negative 2x, and let's say we take v equals to sine 3x. So u prime will get negative 2 times e to the power of negative 2x. V prime, so differentiate sign, will get a positive cos. Okay, differentiate sign dapat cos 3x. Okay, and then we have 3 in front, 3 cos 3x. Okay, differentiate 3x dapat 3. Kita letak kat depan. Okay, ni gonna cross and then plus lah. Alright, so let's put this in our formula for product rule. So dy dx will be negative 2e power negative 2x sine 3x. Okay, plus with 3 e to the power of negative 2x cos 3x. Okay, so let's see if we can factorize this. So we have both term ada sebutan e to the power of negative 2x. Okay, so if we already factor out this value, we're going to have negative 2 sine 3x and then plus with 3 cos 3x here. Okay, so this is done for the first part of dy dx. Then kena differentiate sekali lagi because we want to find our second derivative, d square y over dx square. Okay, so kat sini kena careful over here ada dua term lah. Okay, we have e to the power of negative 2x here. Kat depan ni, lepas tu kena darab dengan this one. So we have to use again our product rule here. Okay, so except for this product rule agak panjang lah. Okay, so u kita a simple term which is e to the power of negative 2x. Okay, and our v ni kita ada negative 2 sine 3x and then plus 3 cos 3x. Okay, sekejap. Mana tulis baik. U e to the power of negative 2x and then v kita negative 2 sine 3x and then plus with 3 cos 3x. Okay, so u prime akan dapat balik negative 2 e to the power of negative 2x and then our v prime. Okay, so negative 2 ni, negative 2 sine 3x is not, we don't have to use our product rule because negative 2 is just a constant. Okay, so negative 2 darab dengan 3 lah. Okay, and then when we differentiate sign, kita akan dapat positive cos. So masih dapat negative 6 lah. Okay, masih ada negative kat sini. So negative 6 cos 3x. And then differentiate cos, kita akan dapat sign, negative sign. Okay, so minus with 9. Okay, so 3 times with, again, kita differentiate 3. So 9 sin 3x kat sini. Okay, 9 sin 3x. Okay, so kita akan cross masuk dalam formula untuk product rule. Alright, so kita ganti masuk value kat sini balik. So we're gonna have, okay, negative 2e power negative 2x times with this whole term of v. Okay, cross kan. Negative 2 sin 3x plus with 3 cos 3x and then plus, okay, which is actually going to be minus here. Okay lah, tak apa, mari letak plus dulu. So plus with e to the power of negative 2x times negative 6 cos 3x minus 9 sin 3x. Okay, so definitely we have to check what can we factor out or what do we need to expand. Okay, so maybe we can try to expand the term first. Okay, supaya kita tengok kita nak dapat term yang sama untuk sin dan cos. So for the first term here, okay, kita akan expand. Okay, so negative 2 times negative 2 dapat 4. 4 e to the power of negative 2x. This is for the term of sin 3x. Okay, then we're going to have minus 6 e to the power of negative 2x. Ni adalah untuk sebutan cos 3x. Okay, then we have minus 6 e to the power of negative 2x for cos 3x. And then lastly 9 e to the power of negative 2x, and then this is sin 3x. Okay, so kita tengok yang mana yang kita boleh simplify dulu. So cari sebutan yang sama untuk sin x. So untuk sin, we have the first term, this one, similar with this one. Okay, dia adalah sebutan yang sama. Okay, with the reading of constant kat depan ni lah yang berbeza. Jadi 4 minus 9, that will become negative 5 e to the power of negative 2x, and then we have sin 3x. Okay, and then the middle term, we have negative 6 minus 6, so that will be negative 12 e to the power of negative 2x, and then here we have cos 3x over here. Okay, so this is our final answer for this question. So sini dia macam panjang sikit lah sebab the second, to get the second derivative ni, kita punya sebutan tu is more than one lah for our product rule untuk V ni. Okay, so there you go for question number 2B. Alright, so done with question number 2B. Okay, for section A, now kita tengok soalan number 3. Okay, so this function of f, okay, is defined by fx equals to ln x minus 1 over x minus 1. So domain dia adalah x must be greater than 1. Okay, and then we're given that the first derivative of this function, f prime x. Okay, so dia dah bagilah the first derivative of this function, f prime x. Okay, dia dah bagi kat kita the derivative This one is already given. Okay, so by considering the second derivative, show that there is only one maximum point. Okay, so maksudnya, ni minta cari apa ni? So, by considering the second derivative, show that there is only one maximum point. So, kena buat second derivative lah kat sini. Okay. So, f prime, okay, f double prime x. Okay, so first of all, kita recall balik konsep untuk maximum minimum point. So, lepas kita dapat f prime kan, selalunya, okay, so kita akan differentiate betul. So, step dia adalah daripada fx, kita buat f prime x. Differentiate function tu. Lepas differentiate function, kita buat f prime x equal to 0. So, kita dapat nilai x equals to a value lah, x equals to a. Then, kita akan buat f double prime x, differentiate sekali lagi. And then, kita substitute x equals to a. So, barulah kita check either value greater than 0 or less than 0. So, kalau greater than 0 is a minimum, less than 0 is a maximum. Okay, so these are the steps lah yang kita buat. Okay, jadi for this question, we are already given f prime x. So maybe what we can do is kita cari dulu kalau f prime x equal to 0, what is the value? Okay, so untuk dapatkan dia punya stationary point lah. Okay, so we can write down stationary point when, okay, so stationary point happens when f prime x equals to 0. So when f prime x equals to 0, we will take this value lah for yang dah diberi dalam soalan ni, 1 minus ln x minus 1, okay, over with x minus 1 squared. Okay, this is equal to 0. So we have 1 minus ln x minus 1 equal to 0. So that will become ln x minus 1 equals to 1. And then x minus 1 equals to e. Okay, e to the power of 1 lah. Okay, and then x is equals to e plus 1. So remember, e ni adalah satu constant yang ada value. Okay, so boleh cari nilai dia lah ataupun just tinggal dulu dalam bentuk e macam ni. Okay, so ni this is the stationary point lah. Okay, coordinate untuk x. Okay, dia tak minta kita cari state the point. Okay, tak, kita just final answer nanti kita just kena show. Okay, show that there is only one maximum point. Dia tak cakap, soalan tu tak cakap find the maximum point. Okay, we only need to show that there is only one maximum point. So tak perlu cari coordinate y pun, tak ada masalah untuk soalan ni. Okay, so now to be sure, okay, proceed to the next step. Kita dah dapat nilai x equals to a. Now second derivative pula. Okay, so from f prime x, we need to differentiate again. So obviously this one we have to use the quotient rule. Okay, So we take our u, u is 1 minus ln x minus 1, and then our v is x minus 1 square. Okay, so u prime akan dapat, differentiate ln akan dapat 1 over x. Okay, negative 1 over x minus 1. Kat sini. Negative 1 over x minus 1. Okay, and then for this one, v prime akan dapat 2 pindah ke depan, x minus 1. 2 times x minus 1 only lah kat sini. Ada guna chain rule kan. So power kurang 1 and then differentiate dalam ni dapat 1 juga. So 2 times x minus 1. Alright, so we're gonna cross and then minus lah because this is a quotient rule. Alright, so now our f double prime x. Okay, so masuk value, we will have vu prime. Okay, vu prime minus uv prime. So x minus 1 square times with negative 1 over x minus 1. Okay, minus with 1 minus ln x minus 1 harap dengan 2 x minus 1. Okay, maybe nak tinggalkan 2x minus 1 juga, tak nak expand lagi. Okay, so everything over with v square. Okay, so v squared again x minus 1 to the power of 4 lah kat sini. Okay, so we proceed to the next line. X minus 1 ni boleh simplify dengan yang bawah. Okay, so we ended up with negative of x minus 1. Okay, negative of x minus 1 minus with okay, ln masih ada. So 2 x minus 1 and then 1 minus ln x minus 1. So madam just rearrange dulu the position. And then here we still have x minus 1 to the power of 4. Okay, so on the next line, we can see that we can factorize out x minus 1. Okay, because we have the same term. Okay, so kita cuba factorkan. So x minus 1, for the first term here, we will have negative 1 minus 2. Okay, minus 2, negative 1. Negative 1 for the first part, and then minus 2. Okay, we factor out x minus 1, and then minus 2, and then plus with minus 2, 1 minus 2, plus with, okay, so kat sini plus 2 ln x minus 1. Okay, so kita darab dengan 2 juga kat sini. Okay, dia expand terus lah, 2 tu. So 2 and then 2 plus 2 ln x plus 1. Okay, and then denominator tadi masih ada x minus 1 to the power of 4. Okay, so barulah kita boleh simplify dengan denominator ni. Okay, so that is gonna be simplify yang bahagian atas ni. Okay, dan potong dengan yang ni jadi kuasa 3. Okay, so final answer, okay, we try to simplify this. We're gonna have negative 1 minus 2, that is negative 3. So jawapan kat sini f double prime kita ada 2 ln x minus 1 and then minus 3 over with x minus 1 cube. Okay, so yang ni adalah reading untuk our second derivative. So untuk kita buktikan second derivative kat sini kan, kita substitute x equals to a, nak check dapat maksimum ataupun minimum. Okay, so kalau kita dapat greater than 0, that is gonna be minimum. Kalau less than 0, barulah jadi maximum. Okay, so kita ganti nilai. Okay, f double prime gantikan dengan nilai x kita tadi, which is e plus 1. Okay, so that is gonna be 2 ln x kan, 2 ln x minus 1, 2 ln e plus 1 minus 1, and then minus 3 over with x minus 1 cube. So x kita e plus 1 minus 1 everything cube. Okay, so sabar, kita ganti dulu, tengok dapat nilai apa. So bahagian atas ni e 1 minus 1 0, so 2 ln e minus 3 over with berapa ni, e to the power of 3 je lah kan untuk denominator. So e cube. Alright, 2 ln e ni dapat 1, so 2 minus 3 is a negative 1 over e cube. So kalau check nilai, you akan dapat less than 0. So kalau dia less than 0, this will become a maximum. Okay, so therefore we can say there is only one maximum point lah. Okay, one maximum point for fx. Okay, sebab tadi value untuk x pun kita cuma dapat 1 kan, then we already check with our second derivative test, confirm lah kita dapat 1 nilai saja untuk maximum. Okay, so that is for question number 3. Okay, for part A, section A of our set. So now tengok soalan ni. Okay, you can take this question, ambil gambar. Okay, and then try to answer this question after this class. Lepas tu submit together, okay, with the rest of your example. So ada nak tengok all the examples, hantar, and then the second part sambung juga dengan kita punya exercise ni. Okay, so ambil gambar jawab lepas habis kelas. Okay, now proceed to section B. Okay, tengok last exercise. Now proceed to section B of the same set, set D. Okay, Madam nak tengok soalan number 1B dulu. Okay, so for question number 1B here, we are given this complex number of Z. And then kita nak cari Z minus 1 over Z. Okay, and then determine the value of the real numbers alpha and beta if alpha plus beta I is equals to this term over here. Okay, so yang ni Madam rasa ada typo lah pada soalan ni. Okay, so this should be Z bar ke atas So yang ni boleh tukar, that will become modulus Z bar minus 1 over Z bar conjugate lah. Okay, yang ni pun sama, alihkan ke atas. Okay, so we want this one bukan pada bawah ni, not here, not here. Okay, so dia pada bahagian atas, tukar kat sini, Z ni, we put that on top. Okay, so Z bar here, Z bar here. Sini pun Z bar, sini pun Z bar. Okay, so Z conjugate. Alright, so let's try to answer this question together. Okay, so dapatkan yang ni dulu. Sebelum kita nak cari modulus dia, kita simplify dululah bahagian ni. So Z conjugate minus 1 over Z conjugate. Okay, so Z conjugate is just 2 minus I lah. Okay, so 2 minus I minus with 1 over 2 minus I. Okay, jadi kita nak try simplify this. So ada dua cara. Okay, tapi Madam nak guna cara yang kita conjugatekan yang the second term dulu. So conjugate this one. I will have 1 over 2 minus I times with 2 plus I over 2 plus I. Okay, so kat sini darablah macam biasa. Sini 2 minus I masih sama. This one will become minus 2 plus I. Okay, like this. And then over with 4 minus I square, which is going to be 5 plus 1 lah. So, negative sini 4 minus negative 1. Okay, jadi sini dapat 5 kan. So, we know that we can multiply with 5 on top here untuk nak samakan penyebut. Minus with 2. Sorry, minus 2 kat sini minus with 2 plus I. Everything over 5. Okay, so the next line, here kita ada 10 minus 25i minus 2 minus I over with 5. Okay, so 10 minus 2, that will be 8. And then dapat minus 6i, so 8 over 5 minus 6 over 5i kat sini. Okay, this is for the first part. Kita belum satu lagi, kita nak dapatkan modulus. So modulus of this will become, so modulus of z bar minus 1 over z bar here, that will become square root of 8 over 5 square plus with negative 6 over 5 square. Okay, kita ambil sekali dengan negatif. So here akan dapat square root of 64 over 25 plus 36 over 25. Okay, so this one kalau you simplify, you akan dapat 4, which is equals to 2. Okay, so this is the answer for the first part. Okay, then kat sini kan kita tengok bila kita nak solve untuk bahagian kedua ni, alpha plus bi ni, kita ada sebutan z bar minus 1 over z bar square. Okay, so kalau madam nak cari terus, okay, down here, for z bar minus 1 over z bar square, okay, this will become square of this term lah. Okay, 8 over 5 minus 6 over 5 I. Okay, I square kat sini. Okay, so kalau kita expand, kita akan dapat 64 over 25 and then minus with 2 times 8 over 5 times 6 over 5i. So that will be 96 over 25i. Kat sini dapat 36 over 25i square. Okay, ataupun madam boleh terus tukar, this one is negative 1. Okay, I square negative 1. So selesaikanlah 64 minus 36. Okay, you akan dapat 64 minus 36. You dapat 28. Okay, so kat sini, mana nak tambah. So this one, kita terus, mari tulis on the next page lah. Jawapan akan dapat 28. So untuk z minus 1 over z, okay, square, kita akan dapat jawapan akhir 28 over 25 minus 96 over 25i. Okay, so ni belum lagi menjawab bahagian yang kedua. Okay, tapi so madam kita terus cari yang ni lah. Okay, so dia nak, okay, hence kan. So tadi untuk modulus ni kita dah ada nilai which is 2. Okay, so modulus darab dengan this term square. So kita akan letak, okay, so put it like this. So z bar minus 1 over z bar. Okay, modulus of this darab pula dengan z bar minus 1 over z bar square. Okay, dia adalah sama dengan kita letak nilai 2 darab dengan yang kita dapat ni. Okay, so 28 over 25 minus with 96 over 25i. Okay, so simplify je kat sini, dapat 56 over 25 minus with 192 over 25i. Okay, lepas tu dia cakap, okay, in this question, given a plus bi equals to this value. So what is the value for alpha? What is the value for beta? So yang ni adalah sama dengan, okay, alpha plus beta I is equals to 56 over 25 minus 192 over 25i. Okay, so kita just keluarkanlah nilai dia. Alpha is definitely the real part. Okay, so 56 over 25. And our beta is the imaginary part, which is negative 192 over 25. Okay, so yang ni adalah solution untuk question number 1B, okay, complex number. So sebab dia ada perkataan hence, jadi awak tak perlu cari semula lah, masukkan je terus nilai yang kita dah dapat daripada first part of the question. Okay, so done with question number 1B. Okay, so we proceed to the next question. Question number 2. Okay, number 2A. We try to do that first. Okay, so question number 2A. We are given this equation. 3 to the power of 2x plus 1 minus 16. Okay, and then we have 3 to the power of x plus 5 equal to 0. So obviously for this question, we need to change it to the same base. Okay, so 3 to the power of x ni lah kita nampak. So we will have here, this is 3 times with 3 to the power of 2x and then minus with 16 times 3 to the power of x and then plus 5 equal to 0. Okay, so 3 to the power of x kat sini boleh tukar jadi square lah. Okay, 3 to the power of x square minus 16. Okay, and then we have 3 to the power of x plus 5 equal to 0. So kita let u equals to 3 to the power of x. Now we will have 3u squared minus 16u plus 5 equal to 0. Okay, so if we factorize this, we will get u minus 5. Okay, and then 3u minus 1 equal to 0. So tolong check lah your factorization here. So the two values are u equals to 5 and then u equals to 1 over 3. Okay, so ganti balik lah kat sini. So 3 to the power of x is equals to 5. Another one is 3 to the power of x equals to 1 over 3. Okay, so for this part, okay, nak dapatkan nilai x ni, so kena ambil log lah. Okay, so ikutlah nak ambil log ke, nak ambil ln ke pun boleh. So katakanlah Meda ambil log 3 to the power of x equals to log 5. So x is equals to log 5 over log 3. So yang ni, kalau Madam just tulis log macam ni, it is always base 10 lah. Maksudnya cari nilai daripada calculator. So dapat nilai kat sini is 1.465. Okay, and for the second one here, this is 3 to the power of negative 1. So our x here is equals to negative 1. Okay, so this is for question number 2A. Right, so for question number 2B, Madam tak nak bincang lah. Okay, just try to go through on your own very carefully. Okay, buat table of sign and then the last part mesti buat number line lah. So ada dua case kat sini. So maybe the first part je lah. Kalau first part, kalau kita nak bahagikan, okay, Madam just akan go through the first part je, first step. Okay, untuk nak confirm balik definition. Okay, so tengok kita ada 3 modulus 3x minus 2 over with 2x plus 3. Okay, and then dia bagi less than 2. Okay, so kita kena buka menggunakan definition. So that the first part is 3x minus 2 over 2x plus 3. So salin exactly and then just remove the modulus part. Okay, bahagian yang kedua, the second one, 3x minus 2 over 2x plus 3. So bahagian di sebelah kanan ni, kita tukar sign jadi greater than and then we change the value lah, tukar kepada negative. Okay, so relationship kat tengah ni, kalau less than dia adalah n. Okay, then kita buat satu-satu, selesaikan case 1, case 2 and then cari case 1 intersect lah untuk n, intersect with case 2. So last kali you buat number line, you akan dapat jawapan kat situ. Okay, so yang ni buat sendiri. Mana tak nak go through in detail. Okay, finish off Alright. Okay, so kita tengok soalan number 4. Okay, soalan functions. Right, number 3 pun awak try buat sendiri. Question number 4, Madam nak bincang. So question number 4A, find the domain and range of this. Okay, so to find the domain and range of gx, so this is our rational function. Okay, so untuk rational function, without we have to think too much, okay, just tengok balik what is the basic rule lah untuk rational function. Kita dah tengok few times. So 1 over x kan, kalau 1 over x, x kat bawah tu. So kalau basic untuk rational function is 1 over x cannot be equal to 0. Okay, so dia mesti greater than 0 lah strictly. then kalau dalam bentuk ni, so maksudnya to take out the domain, we take the value on the denominator. Okay, 2x cannot be equal to 0. Okay, so value here, x is not equals to 5 over 2. So our domain of gx here, domain for g is equals to all real numbers except 5 over 2 lah. Ataupun you terus tulis juga x is not equals to 5 over 2. Yang tu je value dia. Sekejap. Tulis lah, Madam tunjuk lah all real numbers. So real numbers except so except for 5 over 2. Except x equals to 5 over 2. So ni value yang tak boleh ambil. Kecuali. Okay, so lebih kurang je lah. Alright, so for the range pula, untuk this one, range, rational number dia, y tak boleh jadi nilai apa? Okay, kalau y kosong kat sini pun dia akan jadi apa? Dia akan jadi undefined. Okay, that's the word. So undefined So kalau untuk range, untuk g, rational function, range pula adalah always real numbers except for value of 0 ataupun x cannot be equal, y lah, this one y cannot be equal to 0. Okay, tengoklah pada pilihan jawapan yang ada tu dia bagi bentuk macam mana. So as long as you faham how do we find the value for the domain and range. Okay, so for question part B, dia minta kita show that so for question part B, dia minta apa tu? Show that gx is one-to-one function. Okay, so lama kita rasa we haven't really discussed this type of question for quite some time. Okay, so untuk one-to-one function, what is the what are the methods that we can use, okay, to determine one-to-one function? So ada dua. Okay, the first one is by graphical, which is kita buat, kalau graphical method, kita buat apa? Horizontal line test. Okay, so kalau graphical, that is by using horizontal line test. Okay, and then the second one, we have the algebraic method. So kalau algebraic method, x1 must equals to x2. Okay, so kita try, maybe kita guna algebraic method lah for this one. Okay, so kita tengok 1 over, so function gx ni 1 over 2x minus 5. So we take 2, x1 minus 5 equals to 1 over 2x2 minus 5. So kita buat ni adalah gx1 equals to gx2. Okay, so kita akan ada kat sini 2x2 minus 5 equals to 2x1 minus 5. Okay, so going on, obviously yang ni kita akan dapat lah. So 2x2 equals to 2x1 and then x2 is equals to x1. Okay, so sama lah. x1 equals to x2, x2 equals to x1. Therefore, gx is a one-to-one function. Okay, one-to-one functions. No, I'm gonna write down. Okay, so this is our conclusion. Alright, so for the same part of question B, dia minta juga kita find the inverse. So kalau dia one-to-one, dia mesti ada inverse lah. Okay, so for our inverse, remember, we will always use the composite, okay, concept of composite function. So G composite with G inverse of x is equals to x. Okay, so we will substitute this 1 over 2 times G inverse of x minus 5. Okay, so this is equals to x. Okay, jadi kita ada kat sini 1 equals to, so x times with 2g inverse of x minus 5. Alright, so kalau kita expand kat sini, kita ada 2x g inverse of x and then minus 5x. Okay, so kena rearrange balik lah kat sini. We're gonna get 1 plus 5x equals to 2x g inverse of x. And then g inverse of x akan dapat, okay, so for our g inverse of x here, automatic akan dapat 1 plus 5x over 2x lah kat sini. So, this is our final answer. Just rearrangement lah untuk kita dapatkan kita punya G inverse dekat sini. Okay, so this is for question number 4B. Now, we have to show that G composite G inverse equals to X. So, basically, just nak cari G composite G inverse je lah. Okay, then kita nak tunjuk, kita nak make sure jawapan akhir tu kita dapat equals to X. Okay, so kita akan buat G composite with G inverse of X. Okay, this is for part C. So, G composite G inverse. Okay, so G kita, so kalau G composite G inverse, kita akan ganti masuk G inverse lah dalam function G. So kita akan gantikan dengan 1 plus 5x over 2x. Okay. So function gx kita tadi adalah 1 over 2x minus 5. So 1 over 2. Okay, gantikan dengan this term. 1 plus 5x over 2x. Okay, then this one plus ke minus? Minus 5. Okay. So here boleh simplify. Then kita akan ada 1 over with 1 plus 5x. So minus 5x here. Then everything over x. Okay, nampak everything over x. So 5x minus 5x dapat 0. So we have 1 over x. Okay, so 1 over x. So sini automatic terus akan dapat nilai x. So proven lah bila kita buat G composite G inverse of x, kita dapat nilai equals to x. Okay, so dia adalah proven inverse of each other. Alright, so that is for question number 4. Ada 3 part A, B and C. Okay, so just kita go through the concept lah. Okay, kalau dalam soalan objektif mungkin dia akan separate lah. Dia tak adalah combine terus 3 part kan. Tapi dia akan apply konsep yang sama lah. Okay, so we have go through the concept for functions. Okay, now proceed to the next question. Question number 5A. Okay, so ni adalah konsep untuk continuity. Okay, number 5A, continuity. So by using the conditions for continuity of fx at x equals to a. Okay, so as I said just now, continuity. Find the values of m and n. Okay, so we are given this piecewise function. Lepas tu dia bagi tahu dia adalah continuous on the interval of negative infinity to infinity. Okay, so maksudnya dia adalah continuous. Macam ada tertinggal soalan je. Continuous on the real numbers lah. Okay, on the real numbers. Okay, so maksudnya between 0 and 2 ni both dia adalah continuous. So what we understood is bila dia kata continuous on this interval, maksudnya between the values yang kita diberi ni dia memang confirm continuous. So value yang ada pada function kita sekarang adalah 0 dengan 2. So kita akan buat the two conditions lah. F continuous at x equals to 0. Satu lagi dia continuous at x equals to 2. Okay, so untuk case yang pertama, kalau kita buat fx is continuous at x equals to 0. Okay, so what gonna happen here is kita akan buat this one lah statement dia. F0 akan sama dengan limit x approaching 0 from the right of fx also akan equal to limit x approaching 0 from the left of fx. Okay, remember sebab yang kedua ni this limit from the right and left ni sama dengan the second definition untuk continuity kan, which is the limit exists. Okay, so kita boleh terus sambung macam ni lah. Kalau perlu kita boleh direct sambung macam ni. Okay, so f of 0 when x equals to 0, kita ada 2 plus, so kalau kita cari kan, f of 0, it is equals to 2 plus m times 0 squared. Okay, so this one is equals to 2. Okay, now kita tengok pula. Okay, so mana ganti S ni untuk kita proceed dengan this line. So 2 is equals to limit of 0 from the right class is, okay, 0 from the right. 0 from the right yang ni lah. Okay, so 0 kalau less than, ni adalah less than 0, greater than 0. So from the right is the part yang greater than equal to 0. So the second one. Okay, so this one 2 plus mx square. Jadi kita ambil function ni lah. Okay, so limit x approaching 0 from the right is 2 plus mx square. Then equatekan dengan approaching 0 from the left yang less than. So that will become limit x approaching 0 from the left n minus 2 cos x. Okay, so mereka terus combine macam ni. So basically yang left side ni satu value je lah. Okay, so kat sini gantikan. This will become, okay, kejap. Okay, so existence of limit, buat satu line macam ni. No, Meda just nak buat, okay, kejap. Kita dah buat yang cari nilai 2 kan. So kita buat the second one lah untuk existence of limit dulu. Okay, which is limit x approaching 0 for fx. Okay, kita buat yang kiri kanan ni. Okay, so sini 2 plus with mana? M kan kat sini. So 2 plus with 0 lah kat sini. Okay, M times 0. Right side, this is equals to N minus 2 cos 0. Okay, so sini dapat 2. This one is N minus 2 cos 0 is 1. Cos 0 is 1. So N minus 2 times 1. So N is equals to 4 kat sini. Okay, so yang ni kita dapat nilai daripada continuity at x equals to 0. Okay, so now kalau kita tengok second part, kita ambil pula continuity at x equals to 2. Okay, so fx is continuous at x equals to 2. Okay, so kalau fx is continuous at x equals to 2, kita buat pula left side and right side lah of 2 kan. Okay, so yang ni lah the second and third equation. Okay, so first mesti buat F2. Okay, so statement yang pertama ni sama dengan yang tadi. So F2 must equals to limit x approaching 2 from the left of fx equals to limit of x approaching 2 from the right of fx. Okay, so f of 2 when x is equals to 2, that is going to be m minus 2. Okay, so kita ada m minus 2. And then kita tengok existence. So kita buat yang limit x approaching 2 of fx. Okay, so from the right, from the left and from the right, x approaching 2 from the left, the function here is, okay, from the left function dia, this one 2 plus mx square equal to limit x approaching 2 from the right, and from the right is, function is m minus x. Okay, so kat sini 2 plus m2 square equals to m minus 2. Okay, so 2 plus 4m equals to m minus 2. Okay, so 3m equals to negative 4. M is equals to negative 4 over 3. Okay, so dapatlah jawapan untuk nilai M dengan N. Okay, so that is the first part. By using continuity, kita ambil continuous at X equals to 0 and continuous at X equals to 2. Okay, is that all? By using condition for continuity. Okay, so yang ni settle untuk the first part lah, part A. And then part B of the same question, dia bagi tahu kalau nilai M dengan N ni adalah nilai yang berbeza lah daripada yang kita dapat tadi. Okay, M given -2, N is 4. Determine whether fx is differentiable at x equals to 2 or not. Okay, so tulis balik. Okay, try untuk tulis balik kita punya function tadi. Okay, so gantikan M dengan -2, N dengan 4. Okay, so function yang kita akan ada kat sini, N ganti -2, M dengan 4. Okay, so we'll have here -2 cos x plus 4. Then we have -2 x square plus 2 x minus 2. Okay, so untuk first part ni, when x is less than 0. Second one, we have x between 0 and 2. And the last one, when x is greater than or equals to 2. Okay, so kita nak tengok adakah dia differentiable. Okay, not continuity, not about existence of limit, but is it differentiable? Okay, so untuk differentiable, mesti left side limit and right side limit equal lah. Okay, so fine. Check balik definition untuk differentiability at a point. Okay, so kita akan check limit from the left and right. Okay, so limit x approaching 2. Okay, kalau kita ambil -2 approaching 2 from the left, okay, of fx. This will become limit x approaching 2 from the left. So from the left function dia adalah yang tengah ni So -2 times with 2 square plus 2. So value here equals to -6. Okay, -2 times 4 is 8. -8 plus 2 dapat -6. Okay, then kita check for the limit x approaching 2 from the right of fx. So the limit is x approaching 2 from the right. Kita akan ambil function -x minus 2. So x ni kita gantikan dengan 2 lah kat sini. Okay, -2 minus 2, so that will become -4. So what we can see here is these two values is not equal. Okay, so since limit x approaching 2 from the left of fx, okay, is not equal to limit x approaching 2 from the right of fx. So we can say that fx is not differentiable. Okay, so dia mesti nilai yang sama lah baru dia differentiable. So dia tak sama nilai, so it is not differentiable at x equals to 2. Okay, so this is our conclusion. Okay, so that is for question number 5B over here. Okay, so done with question number 5B. Now kita sambung to the next question. Okay, so Madam harap jelas lah for this one. Tolong check balik. Okay, so boleh buat note ke sini. Study. Okay, definition. Definition for differentiability at a point. Differentiability at a point. Chapter berapa? This one, chapter 8. Yang chapter limit lah, differentiability at a point in chapter 8 for by using limits, okay, untuk check differentiability. Okay, now kita tengok last question. We'll discuss question number 7 here. Okay, sebelum ada bagi awak buat exercise. Okay, question number 7, we have a closed right circular cylinder, okay, of radius R and height H. Okay, volume is 4,000. Okay, cylinder right circular cylinder. So bentuk dia lebih kurang macam ni lah. Kita punya cylinder. Okay, so we're gonna have this cylinder. Radius is R. Okay, so we're gonna have a radius R here. This is the radius, and the height is all of this, that is going to be H. Okay, so volume dia given, V is equals to 4,000 cm cube. Okay, and then we are given that the cost, okay, so ni volume, cost for the construction is RM1 per cm square for the curved surface. Okay, bahagian yang curve tu RM1 per cm square, while RM2 per cm square for the top and bottom surface. Okay, so state H in terms of R and then find the radius of the cylinder so that the cost is minimum. Okay, so minimum yang kita nak tengok cost. So relate dengan cost, maksudnya nanti kita kena ada equation untuk cost. Okay, so first of all, we want to state H in terms of R. Okay, so kita buat dulu formula volume lah yang related kan. Kita dah diberi volume. So volume for a closed circular cylinder is given by the formula of V equals to pi R square H. Okay, pi R square H. So kita ada 4,000 equals to pi R square H. So dia nak state the apa tu, mana tadi, H in terms of, state H in terms of R. So H sebagai subject, then we're gonna have 4,000 over pi R squared. Okay, so this is the first part lah. State H in terms of R, settle the first part. Okay, and then we need to find the radius of the cylinder so that the cost is minimum. Jadi kita perlukan formula untuk cost. Okay, so cost ni relate dengan area lah. Okay, sebab dia bagi tahu for the surface area kan. RM1 untuk bahagian yang curve and then RM2 untuk the top and bottom surface. Okay, so for our formula of surface area, that is given by 2 pi R square plus pi R square H. Okay, 2 pi R square and then sama dengan pi R square H. Betul tak formula? 2 pi R square H. No, not pi R square H. 2 pi R H because we take the 2 pi R H, 2 pi R square. 2 pi R square ni untuk bahagian the top and bottom, pi R square. And then untuk bahagian curved surface area, that is going to be pi R square H ke 2 pi R H. Formula cylinder, surface area of a cylinder. That is going to be 2 pi R H. Okay, sorry sini 2 pi R H. Untuk bahagian curved surface tu dia adalah 2 pi R H. 2 pi R square plus 2 pi R H. Okay, so untuk cost, okay, so kita tulis dululah surface area. So bahagian ni formula surface area kan. So untuk cost kena darab dengan nilai cost yang dia bagi kat sini. So untuk bahagian apa ni, top and bottom, which is yang 2 pi R square ni, dia bagi tahu nilai dia adalah RM2. Okay, so we have RM2 times with 2 pi R squared. Okay, and then untuk bahagian curved surface, that is just multiplied by 1. Okay, so 1 times with 2 pi R H. Okay, so sekejap, saya tulis balik. So 2 times with 2 pi R square plus with 1 times 2 pi R H. Okay, so ganti darab dulu kat sini, simplify 2 pi R square plus with 2 pi R H. And then H kita ada tadi kan dalam sebutan R. So that is going to be 4,000 over pi R square. Okay, so sini boleh simplify pi dengan pi, R dengan R kat sini. Okay, so simplify function equation untuk cost, that is going to be 4 pi R square plus 8,000 over R. Okay, so yang ni nampak kita dah dapat equation with a single variable. Okay, so kalau kita buat DC over DR, okay, here akan dapat 2 pindah ke depan 8 pi R, okay, minus with, so here akan jadi 8,000 minus with 8,000 over R square. Okay. So then kita nak cari nilai apa ni, the smallest radius lah kan. Okay. The radius, sorry, kita nak cari value untuk radius so that the cost is minimum. Okay, so kena buat DC over dr equal to 0. So DC over dr equal to 0. So we will take that 8 pi r minus 8,000 over r square tadi equal to 0. Okay, so kat sini 8 pi r cube minus 8,000 r square r cube, okay, equal to 0. Okay, so 8 pi r cube equals to 8,000. Okay, and then our r cube is equals to 8,000 divided by 8, okay, which is 1,000 over pi. Okay, and our r is equals to cube root of 1,000 over pi. Okay, so ni value untuk R kita. So tak apa, dapat dalam bentuk pi pun biar je dulu. Tak perlu tukar dan decimal lagi. Okay, then we want to prove that this will be the minimum kan. So check pula second derivative, d squared c over dr square. So differentiate this again, kita akan dapat 8 pi and then plus with 16,000. Okay, 16,000 over r cube. Okay, so gantikan, substitute r equals to, sorry, this one is cube root. Cube root of 1,000 over pi. Okay, in this equation of d squared c over dr square. Okay, so kita akan dapat d squared c over dr square is equals to 8 pi plus with 16,000 over 1,000 over pi. Okay, sebab dia ada cube kan. So madam cancel off lah. Okay, divide macam ni. So if we calculate this, final answer kita akan dapat 24 pi. And it's a positive value. So greater than 0. Kalau greater than 0, this will be a minimum. Okay, so dia minta, okay, baca balik soalan. Dia minta find the radius. Dia minta radius saja. Find the radius of the cylinder so that the cost is minimum. So radius yang kita dapat ni adalah value dia lah. Okay, so kalau nak buat ayat, therefore, since okay, d squared c over dr squared is greater than 0, when r is equals to cube root of 1,000 over pi ni, okay, therefore we can see that the cost is minimum. Okay, the cost is minimum when the value of our r is equals to cube root of 1,000 over pi. Okay, so cari nilai satu-satu tadi. Okay, so kita buat apa? Kita tengok balik step by step. So kita cari V. Formula V equate to 4,000 and then kita express H in terms of R. Jadikan come up with the equation of the cost, because cost yang kita nak cari maximum, nak cari minimum cost. Okay, so gantikan masuk nilai H yang kita ada daripada equation 1 tadi. Okay, so kita dapat persamaan C with a single variable. Okay, so kat sini single variable kan. So this one, equation with single variable. Okay, lepas tu kita differentiate. Okay, so dah differentiate, nak dapatkan nilai R ni, kita akan equate to 0 lah. Okay, DC over dr equal to 0, dapat nilai R. Okay, so yang ni to check, okay, whether it is maximum or minimum. Okay, so kita gantikan nilai. Okay, so to check maximum or minimum. So bila kita gantikan nilai dekat sini, kita dapat value dia adalah positif, greater than 0. So kalau dia adalah greater than 0, that will be a minimum value lah kat sini. So now because our equation is in terms of the cost, then kita dah prove lah yang the cost will be a minimum when the radius of the cylinder is equals to cube root of 1000 over pi. So kat sini awak nak bagi nilai dalam decimal pun boleh lah. Boleh try cari sendiri value dia. Okay. So that is for question number 7. Alright, so for today's class, untuk set D, okay, yang Madam nak go through just these few questions. Yang lain tu tolong lengkapkan sendiri. Okay, dan kalau boleh hantar jugalah yang dah lengkap. Okay, kalau tak sempat, hantar dulu yang hari ni together with this exercise. Okay, exercise tadi soalan number 1. This is the second one lah. Okay, question number 2. Question number 2. Okay, so salin soalan dulu. Tengok jawapan akhir. Then try to answer this question. Right, so your task for today, please go through salin submit all the exercise yang kita dah bincang together, examples yang kita dah bincang together, and then submit the 2 exercise. Alright, so if there is anything, you can ask me. If not, I think that's all for today's class. So use the rest of this time to complete your exercise, and please submit your work before the due date lah. Okay, madam, before the time. Okay, so I hope everyone will submit this on time. If you have any problem, you can just tell me. So I think that's all from me for today's class. So yeah, we can stop here. Thank you and Assalamualaikum.